Before the video starts, I want to say that the point of this shredder will be to ultimately create 3D printing filament out of the plastic waste, but even before I can get to the extruder itself, I need to have a robust shredder, which is what this video will be about. So how do we get a plastic bottle, or a few plastic bottles, and make it into filament? Well, you have to shred the plastic first, and I converted this paper shredder into a plastic shredder. Just cut out a bigger space for the plastic to go into, and it shreds plastic pretty easily. It has some strain. It wasn't built to shred thick plastic, so if you put anything that's really thick in there, then you risk it stalling, and I had that happen a few times. So so it's best if you cut up as much of the plastic as you can by hand, and then put it in. And obviously the setup here is just, it's a cavity underneath the shredder, and the plastic goes through, gets shredded, and it stays on the bottom for me to collect once I'm done. In this case, this plastic is PET, or polyethylene, and you can shred it with the cap. The cap is high density polyethylene, but it's all really the same. I am not sure about the labels, so I took them off, but I'm gonna try the labels separately in this machine, and see if I get a similar result. I can't quickly Google search if the labels are the same plastic as the entire bottle. So we'll just be shredding the bottle and the caps and such. What I like to do is cut off this top part, because the top part of this plastic is going to risk stalling the shredder. So I like to take it off, and then just cut the entire bottle in half. And you don't even have to cut it in half all the way. And then you get something like that. And then you just put it in the shredder like that. Easy peasy. But the problem now is that with these chunks that I get from the shredder, it's not completely shredded to a desirable small size, leading to clogging and leading to not having a consistent feed rate for this machine, and ultimately you get giant blobs of plastic like this, and all of these are very brittle and stiff. But before I go on to trying to make any filament here, I think it's important to have good material to start out with, so I'm probably going to rebuild this shredder before I go on. So I took apart the shredder, and as you can immediately see, most of the assembly here is made out of metal. And I am very impressed with the construction of this, but once it starts to connect up to the motor, we see plastic gears, and the manufacturers had to work with probably a lot of gear ratios just to have this tiny little motor be able to withstand all the forces that are going on here when you shred paper or anything else. What I'm going to be doing is upgrading this motor, but I'm not trusting these plastic gears, so I'm going to get rid of them, and I'm going to work purely with the metal gear. This whole assembly was really easy to take out, and it was just pressed in there. There was no glue, no screws, nothing. It was just fitted in there. So this should make it fairly easy for me to find a way to connect this over to a motor. Alrighty. This is the motor that we are going to connect to the shredder. So this motor had a bunch of control circuitry that I decided to keep. Obviously you have all the controls for the washing machine here, but on the back you might notice something, that most of these things are just switches. They switch and they don't regulate any electrical current, you know, other than the ignoring the capacitor. You know, this is a air-powered switch, and this is just a bunch of little switches. And so really this motor just can run straight off of the wall socket voltage, 120 volts, but it needs also a capacitor somewhere along the lines, and we'll figure out the correct wiring of it, and we could just plug it straight into the wall just to see if it works.
The process to figure out what wires to use in an induction motor is a whole other video of itself, so I'll save the details for when I upload that video. Now that I had the motor working, I needed to find a way to couple the motor with the shredder, and I had the idea to use the motor's 3 bumps on the motor's shaft with the 3 holes found on the shredder's gear. It almost fit together, but I had to cut the gears a little so those 3 pegs could fit into those 3 holes. It wasn't a pretty fit, but it worked well enough for a test to see if this method was actually worth continuing. The shredder was just simply too hard to move for the motor, and before you ask, I did try it with a capacitor in conjunction with the built-in starter windings, and even then trying to move the shredder directly with the shaft of the motor was never gonna happen. A week passed by and I decided I wouldn't mind spending money on a motor if it meant I could have a working shredder. So I went to a local store and picked up the torquiest motor they had, which was a rear windshield wiper motor. I asked if I could look inside the assembly to figure out if this would be a good motor, but despite being the unique store they were, they said they didn't have the correct security bits to open it. I bought it anyway, thinking luck was on my side, but it wasn't. The motor didn't turn 360 degrees, and it had a plastic gear, which couldn't hold up to the stresses of shredding. I got fed up and started looking online, finding a nice looking motor for just under $30. As soon as I got it, I took it apart, being very pleased to discover everything was metal. This motor had a shot.
So because this motor already came with a threaded rod, most of the work is cut out for me. All I have to do is put a nut on. So once I have these nuts secured on, I can find an appropriate socket that will fit them very snug. In this case, this is a 13mm socket. The whole idea behind this is that once I have a way of connecting to the motor, I grab another socket and make a piece of metal that make a piece of square metal that can fit in both of these, right? Connect these up, and then on this side, on the shredder side, I'll have to work with this little guy, this gear. And so what I'm going to do with this is grind it down in such a way that it will fit into this socket. And once it does, then I can securely mount it on the shredder, and we can have a little test run. So I have ground down this gear now, and it fits fairly well into the socket.
I press fit the gear into the socket and moved on to the square metal shaft that was going to connect both sockets to each other. The shaft I actually found in an alley. It was once part of a rotisserie kit, and was made from a tempered metal, making it stiff and a great material to withstand the stresses for shredding. I made sure all the parts were working together before moving on. I then used the existing frame on the shredder to mount the motor and parts. I had faith in this motor because this 12-volt motor had enough torque to keep going after you tried your best to stall it with your hand. But very quickly I realized this wouldn't last. The frame of the shredder was actually bending and getting grinded away as I lazily didn't put a place for a bearing in the assembly where the socket rested in the frame. And on top of all that, I lost a lot of footage during this point, and this is mainly because a 64 micro SD card failed on me, and I can't show you how this little motor failed. What happened was I was feeding the shredder plastic, and it would have trouble moving the shredder, even during what should have been normal operation. Eventually, I began overvolting it and this motor took a beating. It constantly ran hot and I knew what was coming. Instead of trashing the motor when it failed, I came up with a new idea. Using the worm drive that the motor came with and simply connecting it to a different motor. This time, I could get away with using a less powerful and faster motor because the gear ratio allowed me to. All I did was create a new frame, figured out how to connect the motor to the worm drive, and gave it a shot.
Alright, and we're back. I don't know how much time it has passed from the last clip, but it will be very fast in video editing for you guys. But I've been in Wisconsin kayaking, and I have mosquito bites from my toes up to the back of my neck, and I'm sore all over. So forgive me if I just don't remember where we left off. However, this is the setup we have at the moment. And I have gone and adjusted this piece. This is very important to have this adjusted in just the right way, so the chain that connects over to this motor will line up, and this will also right here line up with the shredder, so nothing, so everything can be running smoothly, and so we will have hopefully no problems. So now everything is welded in place, except this frame, which is bolted in place, of course. But I didn't do too much to it, so I welded a piece of framework over here to support this piece, because this is going to be under a lot of torque. And I welded this whole shredder assembly in place in multiple spots, and I made sure that this was as center as possible to each other, and it's not too hard to turn with my hand, and as you can see, the shredder does turn. So now the moment of truth is connecting up a motor to it, and I think in this condition I'll be able to do a very quick and simple test. I'll need to clamp this down and clamp this down, and then I'll be using a chain. I'll shorten this, and I'll connect both of these up together, and we'll see if this motor has enough power to kickstart this and keep it running, and if there are any problems when it's operational. Alright, 3, 2, 1. Alright, so it works, which is insanely good. I didn't expect it to work that well. I thought it would fail catastrophically. I don't know how to say that word. But this makes a lot of noise, and I think that's just because it's loose. So once I make a proper frame for this, it'll be tighter. And yeah, and I think this will be okay. Here, I'll readjust this, try to make this tighter, and then I guess we'll try to shred something. that is scary. Oh my gosh. No effort at all. Like, this is so much power. It's scary. But I love it. It's great. It works. This is perfect for those thinner water bottles, and I won't have to do any pre-processing of them. I can just put them directly in there and get some nice granules. So that is actually really good for the thinner ones. For these thicker ones, I don't mind like cutting them into pieces and stuff. Like these thicker ones are a bit harder to cut into granules in the first place. But if it can handle these thicker pieces of plastic when it's cut, then I'll be really happy actually. Nope. Not a chance. Not a chance. So now I cut off the top and bottom of that bottle. I'm left with this portion of it, and let's see if it can shred this easily in contrast with what just happened. Yeah, no problems whatsoever. I'm actually excited because I do have a plan for these cut-offs and these this excess plastic that can't easily be shredded. So just look forward to that, because I have a cool project coming underway for these little guys. I hope you enjoyed watching, and especially the whole process to get to this point. So if you did like this video, give it a thumbs up, and I'll see you in the next one.